Hey guys, just a quick video today. I always say quick and it always drags on, doesn't it? Anyway, just a video on improvised Faraday cage. So you may have some sensitive electronics that the recent coronal mass ejections, solar storms, and not to forget the slight issue of sabre rattling from our friends in the east. It's not the worst idea to look at doing something about it. So to that end, we're going to build a improvised Faraday cage out of a, as we can see, large galvanised trash can, cardboard, aluminium foil, duct tape, pen and some scissors. So I'll tape it every stage, we'll get it fit to go, and we will do a function test, whether by a mobile phone or some radios, possibly both, just to make sure that there's no signals can penetrate the can structure, just to prove the system works. Alright folks, back shortly. Alright guys, so what I've done is I've cut some templates. So this big long section here is the writing tends to hint, is the side piece. This will wrap round the inside of the can. This section is two bases, so they will both sit in the bottom of the can. I'll explain my rationale for that when I'm doing it. And last but not least is the lid, and that will be inside here. So let's get some cutting done and see if we can make all this stuff fit together. Back shortly. Right, there's 20 minutes of my life I'll never get back, cutting up some cardboard. So, on the note of the material, so a nice stout card, corrugated cardboard like this will do, or perhaps like a yoga mat, or you could also use like say a camping rolled up foam mat. You know, something that's fairly robust. It'll take a bit of punishment, dings, dents, and more importantly, it'll be an effective isolator, so non-conductive folks, alright? And what we're basically trying to achieve is this bin, right? Steel structure, whatever you want to use, ammo cans, they all make good ones as well. Any waves, so whether it's an EMP or other ones caused by CMEs, which they tend to propagate along longer sections of wires, they'll have a wave. Some are shorter, some are longer, but essentially we want to deflect the waves, okay? We want them deflecting round the can and all your nice expensive goodies in the can, right? So that's all we're trying to do. We're trying to create a shield like this, that anything that's trying to get in will go round, okay? Now, the shorter the wavelength, the more likely it is to get in, okay? So we don't want any gaps that a signal or a radiated signal could go in. So to that end, when we test it, we'll use walkie-talkies or a mobile phone, something like that. And the rationale is if it blocks that signal, then it's highly likely that it will block most, if not all, EMP pulses, anything of that nature that could fry sensitive electronics. Now, I know the solar storm that's hitting the planet over the last couple of days and the weekend is freaking a lot of folk out. It really shouldn't. For the most part, unplugging your appliances, so like say the EcoFlow in the corner there, it's not plugged in, none of the solar cables are attached. Chances are, when we're talking about CMEs and that sort of thing, the most likely damage is to be induced voltage along the tendency of the power lines to act as an antenna. So we can eliminate a lot of the risk by just unplugging the bloody thing. So, excuse me. However, that being said, for the sake of 30 quid for a can and some bits of cardboard, that I actually asked I bought this from Toolstation, and I just asked them if they had any cardboard, and I got this with me, brought it home. So for the sake of 30 quid and an hour of my time, I don't think it's a bad use of time by just taking precautions over and above and putting anything sensitive inside here. And also, the items in the Mylar bags, you can still keep them in that, but if you do something like this, it means you can keep your items in there and dispense with that stuff, but you might want to keep them in it. It'll do absolutely no harm. Okay, so I'm going to test fit these, and we'll build our Faraday cage. Let's crack on. Okay, let's have a little peek inside the can. So we've got rivets here, and we've got a seam, and we've got the base. Right, now you could test it. You could put a piece of cardboard in here on the floor, insulating it from the metal itself, and shut the lid over and do a test by ringing it or calling the radio and seeing if there's any leakage through the seam or the handles and everything else. So the other option is, let's just skip that step and cover them anyway, just to be on the safe side. So best bet, good sturdy aluminium tape, aluminium duct tape. Unfortunately I ran out, so I will be using 3 layers of aluminium foil that will be held in place by duct tape, and I'm going to cover the handles and the seam and the base. So I'm going to do that and I'll come back to you. Okay, so there's now triple layers of aluminium foil covering all the seams. You'll notice there's like a lip at the top here. We've got to leave a conductive edge all the way around the top, so it's important that the cardboard or any other insulators does not come up to here. Okay, we want this part of the structure to meet with the lid. Okay, so we're forming a continuous cage all round about where valuables we don't want to go pop. So there's crushed foil all the way around the edge, it's stuffed in, there's no gaps, it's gaffer tape to reinforce it, and then we'll put in our cardboard insulators and I'll come straight back to you. Okay, that's the first base in. So I did say I was going to talk about the reason and rationale for 2 bases. So I've got 1 base in now, and then I'm going to put the inner part all the way around in a continuous piece of cardboard or insulator as this is, and then once that's done, I'm going to put the second base down the bottom, and that will assist in keeping the bottom edge of the cardboard hard against the sides and in contact. So it only uses about 4mm of space from the bottom, but given that most of the things will be stored hitting the bottom anyway, it gives us 2 edges of protection for accidental tears and damage, and it adds an air of rigidity to the sides by keeping them in close contact with the sides of the structure. Alright, let's get this done. Okay, we are almost at the stage of testing. So, let me just move about a wee bit. So, the lid has got an insulator inside, piece of cardboard, gaffer tape, and I've went to great pains to leave a conductive edge all the way around so that it's metal to metal with the rest of it. Yep, not overly worried about the gaps between that and that. It's perfectly insulated between. Essentially, what we don't want is anything in here in contact with the outside edge. So, what I've done is cut slots inside this, folded it over, and then taped around the top, and that makes it nice and rigid. So, yeah, it's not going anywhere. It's nice thick cardboard and can start putting things in it. So, first thing I'm going to put in it is a radio, and I'm going to try and call it and see what happens. If I get any signal leakage, I might have to put a gasket in place between here and the lid, which will essentially be a piece of folded over aluminium foil tucked all the way around the lip to form a seal between the lid and the bottom. And obviously neither you not want to be touching in here at all. Okay, but let's test it first and see where we go. Okay folks, here we have a Bayfong set to Clyde 1 radio, and we'll put it inside. So straight away the signal's getting interrupted. Right, so it's not receiving an FM signal. Let's try transmitting. Okay, so we've got it on the 5 watt channel, I'll just do a quick test, see if it's getting anything, just sitting in the bin. Testing, testing. Okay. And let's try it with the lid on. Testing, testing. Testing, testing. So yep, that is getting a signal, so that is absolutely no use whatsoever. So we're going to put a gasket on it and try again. Okay folks, I was going to say second time lucky, but it's about the fifth or sixth time at least. It blocked FM radio signals with the walkie-talkie, but it wouldn't block the walkie-talkies at high output or a mobile phone. So I ripped out the insulation and I lined the whole thing with tin foil, all of it, put the insulation back in, tried it again, same shit. Pulled it all back out again, got mylar bags, cut them open, lined it with mylar bags, then tin foil on top of that, then the insulation, and now it works. But oh, and I modified the lid as well, I'll show you. So that's that. Let's try it with the lid on. So I made an insert as well. That was in here. Then I put a gasket around the inside of that, and then you plonk that on. A second. Try that. Let's see. Nothing. Cool. Let's just open that. Right, that's fine. I'll take this shit out of here. I actually thought this was going to be quicker than it was. I've watched numerous videos of people doing these, and for the life of me, I don't know how their tests have actually worked, because it's a decent quality can, there's no obvious holes in it. I've lined the whole thing numerous times, and yeah, it still was a pain in the real pain to work. So let's just do the point again. Yeah, as soon as you put it in, it's killing it. So that's without the lid or anything on. So I think, in all honesty, it'll do its job, but it was a hard slog to get to this stage. And again, I'm stunned how people got, well, I'd like to see the test myself, because I did the exact same as numerous other videos that I've watched for research purposes, and it didn't work. So this is like the fourth or fifth attempt with mylar bags, tin foil liners, and yeah, now it works. But it would, don't get me wrong, it'll block an FM radio signal initially, but walkie-talkies and other things, so smaller wavelengths like those, it wouldn't work. So now it does, but it's a lot more effort to get here. So yeah, have a comment. Apologise for the quality of the video, because I'm getting fed up doing this now and it's been a pain in the arse to do this one. So let me know what you think. I'll try and answer any questions. Have a good one, folks. Bye bye.